It all began with a simple little bean, the Calabar bean. It was a beautiful purple bean when I first got it. But it is not only beautiful in its appearance, but also in the laboratory it has within it.
Chemists had been fascinated by the Calabar bean ever since British missionaries brought it back from Africa in the mid-1800s. From the bean, they had isolated an alkaloid called physostigmine, used to treat glaucoma. But no one had been able to synthesize the complex molecule.
Synthesis is the process of making a natural product or some other substance artificially in the lab, one step at a time, from extremely simple building blocks.
Synthesis was the highest calling for a chemist in the 1930s. A successful synthesis could bring great medical benefits by making a scarce natural product more widely available. Just as important, it proved beyond a doubt that the chemist understood how the molecule was put together.
There were very few alkaloids that had been made from scratch in Julian's time. The synthesis of physostigmine would bring recognition to whoever achieved it. And that's what Percy Julian set out to do.
But Julian was not alone. At Oxford University, another chemist was at work on his own synthesis. His name was Robert Robinson.
Sir Robert Robinson was sort of the dean of organic chemists in England. He was a much respected creator of molecules, a trainer of many PhD students. He was the premier organic chemist of his time.
Moving step by step toward a final synthesis, Robinson had already published 9 papers on physostigmine in Britain's leading chemical journal.
It's a little bit of intimidation. The world is supposed to know, I've got this domain, you stay out of it.
But to Julian, Robinson's approach seemed clumsy. Convinced there was a simpler way, he set out to beat the Englishman to the synthesis. A high-profile scientific victory would be just the thing to get his career back on track. But it wouldn't be easy. Physostigmine was unlike any molecule that had been synthesized before.
It bristled with spots around the molecule where methyl groups were hanging. That's a carbon with 3 hydrogens. There are actually 4 of these. And getting them in the right place is essential to making nature's molecule. It was a formidable chemical challenge for anybody to tackle in the early 1930s.
Julian tackled it the way all chemists do, one step at a time.
When you synthesize a molecule, you start with very small substances you can buy or that you know how to make already. You then start assembling those into fragments of the thing that you're hoping to make in the end. They're called intermediates. And what you're doing is you're following a particular path. This path takes you from the simple starting substances all the way to the final product, the natural product.
To build his molecule, Julian drew on a battery of techniques for manipulating atoms.
One can heat something to a very high temperature. That usually gets the atoms vibrating and makes new bonds possible. You can oxidize something, you can add oxygen to it. You can take oxygen out of a molecule, that's a reduction. We can expose it to pressure. Sometimes we can expose it to light to cajole the atoms to do what we want.
At each step, Julian had to verify that he'd actually made the compounds he intended to. For this, he relied on a device called a combustion train.
This technique takes an organic molecule which contains carbon, hydrogen, nitrogen, oxygen, and burns it.
By weighing the resulting gases, Julian could tell what atoms were present and in what ratio.
How much carbon does it have? How much hydrogen does it have? How much nitrogen does it have? If your compound has the right ratio, you're a long way towards being sure you've made what you thought you made.
And then you repeat this process of purification and of analysis for each intermediate until you finally get to the natural product.
Julian was under tremendous pressure to complete the research, pressure compounded by events in his personal life. He was engaged. His fiancée was the woman who'd been at the center of the Howard scandal, the former wife of his laboratory assistant, Robert Thompson. Born Anna Roselle Johnson, she was a member of a prominent African-American family from Baltimore. She had graduated Phi Beta Kappa and was now working toward a PhD in sociology.
They'd already set, I believe, 2 wedding dates, which he had canceled, and she told him that this was the last time. Unless he kept the new latest date, she would break off their engagement. And he was quite upset by this, but he had no choice but to proceed because we were only a few weeks away from the end.
In 1934, Julian and Pekel sent off their first paper on physostigmine, outlining a new approach to the synthesis. Julian attacked Robinson in the beginning lines of the paper.
To have a young upstart taking on the Pope of organic chemistry in England, naming him and coupling the words failure and embarrassing and low yield is almost unbelievably aggressive.
In many regards, that was a pivotal point in Julian's career. If he were wrong, he could effectively almost write off any research career at that point.
Working around the clock, Julian and Pekel synthesized a compound that was one step removed from physostigmine. Since that last step was already known, this would count as a complete synthesis. But before they could publish, Robinson struck again with his own synthesis of the same compound. The race was over.
He's done it! The shock was almost unbearable. We were not the first, just the Me Too's. Why did he of so much fame, who did not all need the glory, have to snatch the prize from us? Suddenly my eye caught something. Look, Joseph, he's made a big blunder. Our crystals melted at about 39 degrees Celsius body temperature. Indeed, we were able to melt them by closing them in our armpits. His compound melted not at body temperature, but almost 50 degrees higher. He hasn't got it, I cried out.
The melting point of a molecule is a fingerprint. If Julian's melting point is correct, then Robinson's can't be, and these can't be the same substance. And Julian quickly grasps on that and says, you've got the wrong compound.
Julian hurriedly wrote an addendum to their next paper.
We believe that the English authors are in error. This will make us... No. Joseph was a very unhappy man. If we are wrong, we are irretrievably ruined, he said.